We usually start our presentations by stating the pros and cons of being stationed on a Greek island. It's usually a nice icebreaker introduction, but we have to go digital for now. We hope next year will find us on stage, and as we would love to host a TTC event, invite you to experience the blessings of working in such a beautiful place. Kudzu Technologies was established in 2017 with one thing in mind. If LoRaWAN aims to become a global network for IoT, individual networks must be able to prove how they perform, and devices should be made aware of that. We are here to show you how the Kudzu Analytics platform supports network operators on deploying and maintaining high-performance LoRaWAN deployments. We are proud to say that as individuals we have been working with LoRa since the time that LoRaWAN was merely an idea. We had the chance to see it growing. We rode the wave from the first days of point-to-point communication, the first spec available. We've struggled with the first gateway stacks, and we've fought to make backend servers running. Then TTN came and made our lives so much easier. Since the days of point-to-point LoRa communication, LoRaWAN has grown to be an off-the-shelf solution, and this is already amazing. You can place a few gateways, connect those gateways to a backend server like TTN, and there's your infrastructure supporting a few thousand of devices. But to support large-scale deployments, we need much more than ease of use. What happens when multiple network providers of any scale coexist in the same city? When and where is your traffic? How confident are you that sensors on your network are properly configured? We are used to the connected world, where devices connect to gateways through advanced protocols. Those protocols take care of most of the merits of wireless connectivity. You use your Wi-Fi without really caring about retransmitting lost packets. You move around your city without knowing which 4G tower is routing your traffic. And even if you travel abroad, roaming will take care of this. But this is LoRaWAN, and LoRaWAN is broadcast connectionless communication. The tools we use to make wireless connectivity work flawlessly are not there. No TCP/IP stack will acknowledge your packet. No auto-negotiation technique will help your packet reach its purpose. And even though we are used to think like in this way, we must make it clear in our minds. The only tool we have in hand is adaptive data rate. ADR will make sure that your device, under certain circumstances, and if all goes well, will adapt to the most effective spreading factor, balancing reception quality, and through that energy consumption and time on air. But ADR does that at device level, and only based on RSSI. This mechanism might help you balance a few things in your network, but we think that when it comes to network performance, RSSI alone is a weak indicator. Would you dare to change the spreading factor of a few hundreds of devices in a high traffic network, risking your available time on air? Will adding more gateways really solve your problem, and if so, how do you measure that and where do you stop? So we came up with a simple idea. Gather transmission metadata, group them at network level, and provide a bird's eye view of how your infrastructure as a whole actually performs. Kudzu Analytics is a platform gathering, grouping, and analyzing your metadata to report and even call to action on issues important for your network. By connecting to our platform, you can from day one start seeing how your network really performs. You can see how the reception quality in your network degrades over time. You can watch how your channels are being utilized and be reported if they get saturated. You can even monitor the size of payloads being transmitted through your network and much more. Kudzu Technologies has actively been supporting all major TTN communities in Greece, and by that we had an amazing community to test our ideas with. Back in 2018, in the metropolitan region of Thessaloniki, we started seeing something strange. While the city was covered by a small number of gateways owned by the local TTN community, users started having reception issues. Messages were just not getting through. With our analytics platform in alpha version, we asked our fellows to point their gateways in our proxy server and started collecting gateway metadata. The air was bloated. A handful of devices were constantly transmitting a huge payload in spreading factor 12, and those messages were being received by every gateway in town. And there we had it, a nicely deployed network being harmed by misuse. We attempted to locate the source of these transmissions, and by analyzing reception metadata, we became confident that the source of this was somewhere in the hills overlooking the city. Luckily, by digging on the internet, we found two interesting pieces of information: the type of sensor and a piece of news on a local newspaper announcing a LoRaWAN pilot project. With enough proof, we contacted the local authorities and kindly asked them to join us in a consulting session and help them correctly configure their devices. In another case, a group of environmentally aware volunteers decided to install a few air quality sensors in the island of Syros. The sensors were placed, our local TTN community network was there, and a few hours later a dashboard was visualizing the data. However, a few months later the system started to degrade. The number of messages getting through was declining. People were asking for more gateways. In fact, they even started a campaign to fund more gateways. With 4 gateways in a range of less than a kilometer, high in the hills, in a low density town, reception should not be the problem. And we had the tools to prove this. Again, we asked gateway owners to use our analytics platform and give the system some time. A few hours later, we already knew what was going on. Coverage was not the issue. Messages were being received by almost all gateways with slightly different RSSI. However, the platform started alerting for suspiciously heavy downlink traffic. Turns out the sensors were not storing their keys. Every time they woke up from sleep, they had to use over-the-air authentication techniques. And by doing this, they were randomly picking up at dev nodes. With every OTA attempt, finding an unused dev node was getting harder and harder, locking the devices in a constant loop, trying to find an unused key. Bad implementation of the LoRaWAN protocol on an otherwise amazingly accurate air quality sensor. But we went a bit further. Before contacting the manufacturer, we digged on the analytics to see more. Channels were misconfigured. In fact, they were not configured at all. The device was constantly transmitting on one of the 3 officially pre-configured channels. The payload was 51 bytes, right there on the limit of spreading factor 12. We contacted the manufacturer with proof, and he was amazed by the insights. He soon came back with a new firmware and a new product. We also saved the users a few hundreds of euros that would have been put on gateways that didn't really need. Speaking of which, I will talk to you about other type of issues that you can find with our Kudzu Analytics platform. Things like gateway criticality and network utilization are common problems in this type of networks. We have explored deployments where specific gateways route only a few messages, but these messages are uniquely received. This makes those gateways underutilized, but quite critical. We have explored deployments where sensors transmit at very specific time slots, causing collisions which can easily be avoided once you have a systematic look at the data. More than once, we have seen deployments not working as expected and causing users to lose faith on LoRaWAN. Most of the time, LoRa is not a problem, and we are here to prove to our users that their easily deployed off-the-shelf solution will only act as one only when installed and monitored properly. Quality of your LoRaWAN service is more than just coverage and way much more than serving your network sensors. Analysis of your network performance is not only useful to troubleshooting, it's also a powerful tool for securing your investment in the network. Analyzing your network performance in real time is an excellent way to get insights for when to invest in more gateways, when to plan your second-day operations, and even where to do so. Even more, with LoRaWAN roaming becoming a reality, performance of your network will be a valuable metric. Routing traffic of other networks is the next big thing towards a global scale IoT network, and having quality and performance measurements accompanying your network can be an essential tool to drive your future development decisions, especially when combined with other types of data such as economical and development data of your area. In Kudzu Technologies, we look ahead towards an ecosystem where network KPIs will trigger data-driven actions on the device at the radio level. We are exploring those KPIs, but we're also building mechanisms which makes devices aware of the status of the network. This will enable end devices to make the right decisions about which information should be transmitted through which upstream channel and when exactly should that happen. We build radio abstractions for multi-radio devices to make sure that your next IoT product will be able to evaluate how your message should be upstream based on network quality, battery life, and message criticality. Our IoT firmware and its supporting services are built with this in mind. Future IoT devices will be deployed in an increasingly diverse environment, and developers must be able to design them without the need to worry about that. We bring network quality and performance insights to the connectionless world of LoRaWAN, and we make this available at all stages of the stack, from high-level network operator view down to developing end devices. This is just the beginning of Kudzu's attempt to redefine connectivity.